Hey math people, just making a quick video on some Desmos tips given that the SAT is now digital and Desmos active. So I'm just going to pull some questions directly off the College Board site. I'm just going to scroll down to practice and preparation from their SAT page. Just hit start practicing. What I suggest underneath the practice test is to definitely do the digital SAT practice in their app. I think that this is going to simulate the experience a little bit more. I don't know, one-to-one with what you're going to see. All I'm doing right now is just Desmos focused tips. So I went to the full-length linear non-adaptive test, and well, this is the test for that. So this will just give us a good idea of the type of questions that you'll see on the SAT. So I'm just going to go through it and just find little moments where it's like, oh yeah, I can use Desmos here, and show you some tips on that. So right off the bat, right away, sometimes Desmos can be useful for just simple calculations. You can also use your calculator that you bring on the day of the test, but you could do basic calculations on Desmos. We'll start light, basic to the point. 10% of 470. Okay, so the first few questions are going to be pretty straightforward. In this case, it's just 47. So what's the point of this little takeaway? You could do basic calculations on Desmos. Looking at something like 2, obviously it's linear, and I think just about every algebra student I know can solve a 2-step equation. But just pretending that we don't know how to do it, another way you can utilize Desmos here is you can graph the equation, and to find the equation that matches that. So if I graph like 4x is equal to 108, actually, you'll see that that's, not the solution here because these don't map onto one another. They don't replicate the same vertical line in this case. So if I go ahead and switch this to, say, 24, you can see these don't also match. So choice B is out the window. And it looks like, hey, look at that, 12 is our solution. They overlap one another. Of course, you shouldn't use Desmos if you don't need it, right? So in this case, I really don't need it since it's a 2-step equation. But the demonstration here, the point here is that if it's an equation that you're meant to solve for x on, not an equation of like some function f of x or y is equal to x, you can still solve it using Desmos. You can actually just type it in and see where you get the overlap. Okay, so something like 3, this would be an example of probably a problem I wouldn't use Desmos on because it's really just a setup of a inequality. So I would say any setup problems, setup equations, setup inequalities, don't use Desmos on those. And pretty much the ones that are like function based. So like looking at 4 here, you have some function x squared plus 9 for which values of x is g of x equal to 25. You can absolutely use Desmos in situations like this. I'm pretty sure it even takes g of x if you're not, if you want to type it in verbatim, but you don't have to do that. You can just say y is equal to. But in this case, you're just looking for points of intersection for which values of x is g of x equal to 25. You can actually just straight up type in g of x is equal to 25, and you can just find these moments. So it looks like you have an x value of 4 and an x value of -4. So in this case, it's looking to be A. 5 is like a probability-based question. I would not use Desmos here. 6, more of a wordy problem. Wouldn't use Desmos in this situation. This one looks like a function. So you have some f of x. Okay, so Desmos can also handle function inputs. So if you have some f of x is equal to 7x plus 2, if you want f of 4, it'll give it to you. Looks like in this case it's just equal to 30. So Desmos active here. This one's another setup, 8, so not really a good Desmos one. And same thing with the geometry problems. Anything geometry based, don't I think you're going to be wasting your time if you're going to be playing around with their functions here. Although I will say, if I didn't know it had a distance formula calculator, and I didn't know it had a midpoint calculator, so it possibly could be beneficial here in some situations. Does it handle ordered pairs? Can I do 2, 3, like 4 comma 5. Yeah, so it can do distance formula, it looks like, and it can also do midpoint formula, but I wouldn't, and you can just do midpoint with the same thing, right? Actually, you can probably even type it out as well. It'll treat each value as like a variable until the whole word is spelled out. Oh, does it actually just graph the midpoint too? Yeah, that makes sense, right? The midpoint of 2 and 4 is 3, and the midpoint of 3 and 5 is 4. So I don't know. Any angle-based problem? No. That's maybe the takeaway here. All right, look at that. Systems of equations. Absolutely. Desmos can handle these scenarios. We're just looking for the point of intersection. Nice thing about Desmos is that you don't have to isolate y. You can just straight up type in as is. You're just finding that point of intersection here. So that would just be at 15 comma negative 45. So you get that value of c here. Okay, so this is a linear regression situation. I would say this is like a light use in this situation. You could technically graph each of these and try to find which one seems to make most sense. So if I were to sit here and graph each of these solutions, does this seem to model this line or this set of data? I'm going to say no with the current setup that I've done it with, right? But because this is up in the first quadrant, and the first quadrant here is completely blank. But sure enough, if you play around with all the solutions, you will end up getting the one that models that quadrant 1 downward trend slope. And it looks to be, this option B here. So sure, you can use Desmos here, sort of, right? Super technically, you can actually graph each of these ordered pairs and do a regression model on this, but I think it's an enormous waste of time. Don't do that. Okay, so for 12, the graph is shown here. Sure, you can maybe type this in for how many values. Now, this is more conceptually driven. For how many values of x does f of x equal to 0? Yeah, no, they just give you the graph. In this case, we're just trying to find out where the zeros are, and in which case there's 3 of them because we crossed through at -1, 4, and 7. I mean, this would be a situation where, so maybe the takeaway for something like this is that you can type in like coefficients that are like constants that you can have some sort of control over. And let me just show you. I wouldn't use it in this situation, but sometimes it could be beneficial. Plus cx plus d. If you just hit add sliders for all, you can actually kind of even sort of replicate this situation if you want to. But again, a waste of time for this particular problem. This would be maybe something that I would utilize for a problem where maybe they ask you to find some a plus b plus c plus d where there might be 3 solutions or something along those lines. They do ask questions like that, so this is a useful skill, just not within this particular problem. Okay, 13 is another like wordy problem. I'm going to say, well, I can read through it. In a lot of the cases for the word problems, I would say the setup of the scenario is that reading comprehension piece to set up is going to be the battle, not the solution per se. So I'd say probably not necessarily a Desmos-based problem. You're not going to get this wrong because you solved it incorrectly. You're probably going to get this wrong because you can't set up the scenario. What is one solution to the given equation? Okay, so you can do equations set to 0 as well, but if I'll show this in 2 ways. Don't use z, don't use their variable though. Use x because that's how Desmos reads the independent variable here. So minus 24, and you have the x-axis within Desmos, not the z-axis. Yeah, so I mean, right away you can just say the answer here is 2. But if you zoom out, you can actually see. So it's a quadratic. It's going to have 2 solutions. It's also -12. If you don't like that approach, you can actually just graph the quadratic, and you can say y is equal to 0. You don't even have to set y is equal to 0. You can actually just click the zeros, and it'll give you the same solution. So what is one solution of the graph? It takes both of these answers, both 2 and -12. Again, another word problem here for 15. I don't necessarily think that's going to be the issue. The Desmos, or the solving aspect, probably just the setup. Okay, so you actually can use Desmos for 16. I would just use your understanding of factoring in order to solve this. But let's just say, I don't know, you just woke up and just not feeling great that day, and you're like, listen, forgot just about everything with factoring, which, sure, you know, I get it. So what you can do is you can actually set this equal to a constant. I wonder if this is going to work. So maybe I just set it equal to the number 2 or maybe the number 1. And what I can do is I can just set all these solutions equal to the same value. And if you get an overlap, it's the same thing. This is a silly way of doing this problem. I would not do it in this fashion, but the whole point of this video is more so just like, can you use Desmos on it? So here, you don't get the overlap within the first answer choice, but you know, I'll jump down to what the actual answer is. I'm pretty sure it's C, so we're going to go ahead and plot that out, and we should see an overlap. So, you know, do you need to know how to do factoring for this problem, even though it's just a GCF? No, you don't, because you can actually see this overlap. I'm wondering if the blue and black is hard to see, so I'll switch it to red and blue. You can see that you got this perfect overlap here. Okay, so you can use Desmos on this one. The answer is just C. Okay, so you're given an equation. Okay. Neighborhood consists of a 2, I don't know that word, park and a 35. Oh, okay, that's cool. That word again. This SAT does stuff like this, right? Just like throws in kind of random words to try to throw you off. The total number of trees in the neighborhood is this number. So the equation, yeah. So this is just a reading comprehension problem. You could graph this onto Desmos. That'd be a waste of time though. All right, so let's look at this one. The graph shows the relationship between the number of shares of stock from company A, which is X variable, and share stocks of company B, which is your Y variable. That's Simone. Just like, love the names that they kind of come up with. Can purchase. Which equation could represent this relationship? Okay, so yeah, you could sit and, I don't really know if it's the best play here again. So for some of these situations, I'd say just if you have a better understanding of the equation, like looks to me like we have an intercept at 0, 40 and then 60, 0. If you have a better understanding of this problem just through your own understanding of algebra, I wouldn't sit here and use Desmos for some of these problems. So like, you know, the answer is B for this one. I know standard form. I know that this is kind of just a standard form setup to the problem where you're given the y-intercept here of 40. So, you know, 12 times 40 is equal to that 480 value, and then 60 times 8 is equal to that 480 value. So I just know standard form, so I know the answer is B in this case for that reason. But let's pretend again that we don't know math, right? We're just utilizing the tool that we have. You could just sit here and graph each of these and see which one matches the equation that or the graph that is provided. So, you know, for example, if I do this 8x plus 12, you know, this is not right. This is not this line right here, right? So you could just sit here and graph each of these and find the match if you want to. Another geometry problem. So no, I would just know geometry for this one. So just be mindful that, I don't know if it's on this right here. Yeah, they give you all these reference formulas. So if it's like a plane geometry problem or a like 3D problem, don't feel like you have to have the formula for cone memorized, right? Volume of cone. They'll give it to you. All right, so keeping that party going here. Frequency table. What is the maximum data value in this set? It's just 14. Okay, so it's just a frequency table, and you have 6 data values that are 14, so 14 is the highest out of all of these. No Desmos necessary for this one. Okay, 21. This is a Desmos-based problem, or at least it could be beneficial with this problem to some extent. So a circle on the plane has a diameter with endpoints. Okay, so you can actually do ordered pairs on Desmos too. It could be beneficial, maybe not, but you know, to me, I see how this could be beneficial. This is the length of the diameter, so I want to create a circle that looks like this. And then I can manipulate, okay, an equation of this circle is, I didn't read any of these ahead of time. I'm just kind of doing this on the fly. Yeah, all right, so I'm going to go ahead and just type in that equation, right? So like, let's just say, I didn't really honestly read a lot of this problem. And you can see that, I don't know, I'm actually kind of getting somewhere with it just by knowing how to type stuff into Desmos. And whether or not that's a good thing is a whole nother conversation. But hey, this is the world right now. So you can see that this is not, oh, it's a minus, not a plus. So this is seeming to line up, right? This is the center of a circle. I actually can kind of manipulate the radius of this circle. You can kind of just drag it until you get like a little overlap here. You can actually see the radius is equal to 5 for this problem. So I mean, the problem's just done in that case, right? I don't need to know how to solve. So, this is H, this is your H value, this is your K value, your vertex of your center of your circle. You don't even need to know that for this problem. You can just plot this on in, and if you know how to slide this little bar, then you can solve it that way. Another geometry problem, so no, probably not Desmos on this one. Unit conversion, right? Unit conversion? What is the area? No, this is an area. No, not Desmos, a little geometry based. Okay, this one maybe. I'm going to go ahead and erase all these little points here. Actually, maybe both of these. So for a line H, so we're going to be graphing a line, shows 3 values of X and their corresponding value of Y. Okay, line K is the result of the line translating, line K is the result of translating the line H down 5 units on the XY plane. Okay, this is a little wordy, but I think Desmos can maybe handle this one for you. You can actually graph ordered pairs via a table. I don't know if you saw what I just did. I'll do it nice and slow. If I hit plus and then I hit table, maybe it's beneficial here, maybe it's not. Again, I don't advise. So if you're here with me this long, you're actually kind of probably liking the Desmos stuff. But if you know how to do the problem, don't feel like you need to sit here and type all these values, right? Because that's going to be a waste of time. Yeah, this is looking to be a line here. So you can actually do a linear regression with Desmos, and I can do a little quick teach of that. Last I remember, it's Y, and then you can do underscore 1, and then this little squiggle. And then type in mx underscore 1. Oh, that's a 1 right there. It's just hard to see, and I also typed in incorrectly at the beginning. You can see here that it'll actually regress the line here. So the line is y is equal to 6x plus 22. And what is it saying here? So line K is the result of translating H. So this is H, because this is, for line H, the table shows 3 values. You can see it's got an R value of 1, and it crosses through them perfectly. So this 6x, I can actually get rid of all this. I don't need it anymore. This 6x plus 22 is the line for this table. And what is it saying? So K is the result of translating H down 5 units. What is the x-intercept of K? Okay, so bringing it down 5 units. Yoink. So just scoot it on down. So now we're looking at K. What is the x-intercept? That number. Another thing that Desmos can do is, I think it can do Desmos. So this is negative 2.833. Can it do, can it convert from a decimal to, maybe it can, from a decimal to fraction? Okay, so let's just say, I'm clearly in a situation where it's like, oh shoot, well, I don't know how to do that. Well, one, hopefully you just have the number sense to see. This is like between 2.5 and 3. So if you look at your answer choices here, let's see, this is like a little above, 11 over 3 is close to 4, so that's not it. This is 4.5, that's not it. This is like 9-ish, that's not it, or 8 point something. So it's looking like choice D. I'm just using like basic number sense. And if I can type correctly, you can actually just see by typing in that value, that negative 2.8. 3. A lot of 3s there. Maybe a lot. Maybe an infinite number is the same value. Okay, so it looks like it's choice D. So again, handle this totally on Desmos. Notice I'm not writing anything. Right? This is a wild new test, right? You know how to use this tool. So I don't know what I'm going to call this video, but it's like tips and tricks on Desmos, or know how to use the tools on Desmos, because I'm solving a lot of these problems with Desmos here. Okay, in the XY plane, we got a quadratic. It intersects the line y is equal to c at exactly 1 point. Okay, so you do need to have an understanding of how quadratics behave to handle this problem, right? So if I go ahead and graph it, negative x squared plus 9x minus 100. Oh no, where'd it go? JK, it's down here. So zoom out if you can't get it. If you get an error, so let's just say I typed in something wrong here. It'll tell you. You can just hover over this little caution thing, and it'll tell you what you did wrong. So in this case, we're good. Or you can just zoom out, right? So if your home value, this is like the home view, -10, 10. Depends on, I think, the resolution of your monitor, but just kind of centered at the origin here. But if you scroll out, here it is. Okay, so you do need to understand what a quadratic does. So if we want to intersect a quadratic at exactly one point, this is going to be at its vertex. So it's actually nice that Desmos kind of grays. Give me a sec here. Grays the points of interest here. So you don't have to do any. I don't know if anyone has any experience with like the Texas Instrument calculators, the older ones, the 84s. So you'd have to do like second, and then find the maximum, second calc, I think it is, and then find the maximums going to the left and right of the value. It takes a long time. You have to enter 3 times. Here you don't. You can just kind of click the point. Anyway, so what is the value of C? This is just asking for the Y value, right? So it looks like it's negative 79.75, which again, we can just sit here and just see which one is equal, right? It's not negative 100. It's not negative 9/2, which is negative 4.5. That's like a beta answer there to an extent, right? Because that's 4.5. It's probably going to be C. I don't know. Let's see. Negative 3.9/4. And yeah, you get that same value that looking like the answer is C here. Okay. More systems here. So again, you can hit that home button to get back home. I don't know what percentage of the problems we answered here already with Desmos, but it's a good amount. And then it looks like this little portion of the test is done after, and we can look at some of the next one too, the next little module, I guess. All right, let's see if we can handle it here. For each real number r, which of the following points lies on the graph of each equation in the xy plane? All right, these are a little interesting. Let's go ahead and just type it on in and see if it can kind of handle it for us. I would say anything that gives you equations, I'd be like, yeah, maybe I can use Desmos here. So what's going on here? Okay, it's a little hard to see, but I'll change the color here. But this system is these are the same lines, right? If I multiply top by 5, you actually get bottom. So for each real number r here, which of the following points lies on the graph of each equation? Each equation, that's kind of goofy, right? Because they're the same equation. So actually, since they're the same equation, I can just I'm pretty sure I can just type these values in. Let's see what happens if, there's a few ways I can handle this. Why don't I just like type it in as an ordered pair? Let's see kind of what happens here. +7, and then comma. I'm just typing in the first one, just letting good old Desmos do all the work for me here. I wrote down no math and probably answered like a third of these problems correctly. Let's try to label this point. Where are you at? Okay, so nope, that doesn't seem to be a match. Can I really just sit here and nah? No, ain't no way I can just sit here and just type these out and see which one's a match. Oh, I can't read. I'm trying to type in this one right here. But you can, is kind of what I'm suggesting here. Just add a slider for that R value and let it rip. Look at that. Whoa. So what's the answer to 26? Looks like it's choice B here. And then over here, this is a triangle. So no, this is I would probably not use Desmos for this. I would just use geometry, use your knowledge of geometry. I don't know how many of those. I'm kind of curious. I got to count, right? How many of those were there? So that's 1, 2, 3. No. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Half the test. I just did half the test without really, writing anything on a sheet of paper here. I just used Desmos, good friend. All right, we can look at the second half here. So more of the same. So word problem, I would say no. I'd say you just have to know how to transcribe, using your reading comprehension skills to see which choice here is the best fit. Okay, system, yeah, we can use systems, right? So 3x plus 12, and this is your negative 3x plus y is equal to -6, right? You can just figure out what that point of intersection is. Looks like it's here. It's 4, 6. So it's asking for the y value is just 6. Another setup here. So I'd say no to this one. No, this is like another reading kind of problem here. So I'd say no to that one as well. Geometry problem. This is just Pythag. Yeah, so Pythagorean theorem. So no as well. So a lot of no's in a row, but these are some of the earlier ones where hopefully you wouldn't have to use it. Let's go ahead and read 7 here. The x-intercept of the graph is shown. What is the value of x? No, again, this is sure you could graph this one, but don't waste your time, right? What is this? Just for the fun of it. This is just x minus. Maybe this is what I'll do. If you know all of your, so this is a quadratic. I'm just gonna go ahead and type in vertex form. So the answer is just 7 here, right? We don't need to use Desmos on this one. It's just the x-intercept. But what can I do as like a helpful tip? It might be beneficial to know all of your quadratic setup equations. So another quadratic setup would be like its factored form, or its sometimes called intercept form. The sliders are nice. It kind of can help you out in terms of, maybe you're trying to figure out some values to match some sort of function. It can help you find those values just by using the sliders. So what it does is it will kind of gray the points of interest, usually the x-intercepts, y-intercept, and then also the mins and maxes. So anyway, I wouldn't use this here, but Desmos is a nice tool for figuring out function transformations, right? So, all right, what is the solution? So remember, you don't have to know how to solve equations for this test anymore, which is weird world, right? Again, even though this is just a linear, where are we at? The answer is just 40 for 6. Even though we know it's linear and it's a 2-step, we can solve it. It can solve a lot of equations for us. So let's just say I'd list some sort of nasty quadratic that I don't want us to have to use quadratic formula on. It'll find the solutions for me. It doesn't have to be just linear. Okay, so the function, here it is. It's just a line. What is the y-intercept? Okay, so it takes f of x, by the way. So 1 over 10 x minus 2. And it's asking for that y-intercept. So the y-axis is right here, just 0, -2. Choice B. All right, cubics. I can graph cubics too. Defined by this. Oh yeah. So okay, so this is a good example of like a function parent, not necessarily a parent function, but a function transformation. So I can go ahead and I can graph this. F of x is equal to 7x cubed. And I can just sit and read, okay, well, it says in the xy plane, the graph of g of x is the result of shifting the graph 2 units down. Which equations defines that? Well, okay, you can know that, the constant at the end is going to help us shift our y-intercept and dictate our vertical shift here. But if you don't know that, you can just sit and graph all the solutions, right? Oops. Actually, yeah, I created new little tabs here. So I can do y is equal to, let's just say, I think it's the first one, right? So 7 over 2. What is that going to do? That's going to kind of compress our function a little bit, actually, all to the 3rd power. So you're like, oh, nope, that's not it. That doesn't shift it down 2 units. But if I create a new one, right? So is this problem? Obviously, we already have the answer. Or I don't know if that's obvious, but the choice is D. But you could sit here and just kind of play around with the solutions and be like, yes, okay, this is shifted 2 units down, 0, 0 to 0, -2. Stop when you know you have the solution, yeah? But you have a lot of capabilities here still. Just trying to demonstrate all of them, that's all. Okay, so which expression is equivalent to this? Again, you can sit here and you can actually just graph this. Just set it equal to some arbitrary constant. Arbitrary just means it doesn't really matter what that constant is going to be. Or you can just set it equal to y, honestly, because this is just an expression of one variable. So I'll probably just do that. I'll just set this equal to y for this problem. So this is just kind of me, oh no, I don't know how to simplify polynomials by subtraction here. Oh darn. But no big issue. You can just go ahead and graph them. and to see which one's a match. So I went ahead and graphed just choice D for no reason really at all here. Doesn't look like it's a match. What is probably the answer to this one? Probably A. So I'm going to go ahead and graph that just a plus a 10x. And hey, look at that. It's a match. Right? They overlap on one another. Sorry if I hit the keyboard too hard there. All right, so solutions to systems. So yeah, this is a nonlinear system. You have a line and a parabola, but hey, guess what? I don't need to know that. I don't need to know that. I can just go ahead and graph the line and graph the parabola. 7 is our little shift here, and then is equal to y. You can even type it in the way that they have it here. Just scroll up, zoom out. Looks like it's 3, 100. Okay, so 12, another one. So actually, what is this? This whole page, Desmos can handle all these problems for us. It won't take P of n, by the way. It will. I think it takes P of x. No, it doesn't take P of x. Yeah, you could just do y is equal to for this one and just change the n's to x's. Remember, n is interpreted as a. Give me a sec here. Like a scalar kind of constant value on Desmos. So yeah, you got to change those to x's. So okay, what is the n value? So what is the input when your output is equal to 56? So just set your output equal to 56 here. I zoom out, find that point of intersection, and bam, the input would be 2. All right, so yeah, this whole page, Desmos is a beast. 13, nah, it's just complementary, supplementary angles, all that stuff. What is it? These are alternate. You can do alternate interior to supplementary here if you want to. Given the transversal C, but wouldn't use Desmos on this one. This one right here is interpreting. So sometimes you have problems where you're given words and you have to find the equation for it. Sometimes vice versa. So you're given the equation, you have to interpret the equation. So no, not this one. You just have to know how math works here. Okay, mean. Yeah, I actually think there's a mean function built into this. So there's a few ways you can find it. Give me a sec to figure that one out. Functions. I'm pretty sure if you go down to statistics, hey, look at that mean. You just type in mean and then parentheses. Yeah, you can tell I had my coffee kind of recently here. There's medium, min, max. Probably don't have to use a lot of these. Definitely don't. What is the Spearman of? No, you're not going to have to do that. Probably just mean, median, min, max. We saw max already. Maybe quartiles, but I doubt you'll have to use the rest of these. Anyways, you can just type in the numbers. Wow. We know math. we know math good. 17, 26. But, it's using your resources. That's kind of the philosophy that the AP exam is, or not the AP exam, the SAT is switching to, is like, do you know how to properly use your resource? Because the reality is, if you're using your Desmos on all of these, the ones that I'm like, should you use Desmos on the 2-step? Absolutely not. That's a waste of time. But the idea is that you can, and I'm just showing the tool, right? But the philosophy behind the SAT change is that this is a tool, and you need to know how to use it. So I understand. All right, let's do the next one here. 16. G of x is equal to, I don't know if it was obvious, but the answer to that one was 10. Okay, g of x is equal to, I'm looking at 16. G of x is equal to x squared plus 55. What is the minimum value? Sick, 55. This is cool. All right. This one here, no, it's a percent change, and it's no, it's increasing by. Kind of just want to solve it for fun now. So it's a percent change and it's increasing, so it's an increasing exponential. But so choice C is the answer here. Percent increase is exponential and it's going up. But again, you don't have to. I don't know how you'd use Desmos here. Okay, so. Increase by. You can kind of use Desmos for 18 because, okay, so you have some sort of population. It goes up by 7% from one year to the next. 2016, the population is K times the population of 2015. What is the value of K? So percent increase. I'm going to say probably not on this one, but I'm going to kind of force a Desmos use here because that's the point of this video. Let's say your population is like 10. And, okay, you think that's... so it's percent growth, which is exponential, and you think, oh, okay, oh yeah, 7%. Okay, it's gonna be times 7, yeah. Wonder Oh yeah, so you can like plug in like 0 and then plug in like 1 and be like, ah, shoot, you know, going from 10 to 70, that's not going up by 7%. I want to go by 7%. So you can like play around with the values here. I know that percent growth is 100% plus 7%, which is 1.07. This is a bit of a stretch, actually. Yeah, this is a bit of a stretch to use Desmos on this one. Because technically you can say at like year 0, you're at a population of 10. At year 1, you're at a population of 10.7, and then you can create that ratio. Yeah, I wouldn't use Desmos on this one. This is just understanding how. I mean, the choice is still, choice C here, this 1.07, but I wouldn't say Desmos is a good problem to use on this one. Here you can, I think. Yeah, you can use Desmos on this one. Just plug in an arbitrary value for A. So let's just say I plug in like the number 6. So I can do 6 to the 11 over 12. This is just your testing your understanding of rational exponents and just simplifying fractions. But, let's just pretend I don't know any of that. Okay, so underneath the number theory, you'll find nth root. So with the square root, I wasn't able to get access to this index here. Does it take nth root? Can I just type in like nth root? Oh, it does. Sweet. Okay, yeah, it's way better. I wouldn't. I know because I know it is square root, by the way. Squirt is square root. CBRT is cube root. And actually, you can probably just even change it from here. But if you type in nth root, you can actually just get access to the radical that way. But anyway, so I'm going to go ahead and just type in a few of these choices here. So I suspect it's either B or C, so I'm just going to 50-50 it and not really use my brain because I want to get the same kind of fraction idea. I'm sticking to this value 6. It's an arbitrary value. And then I'm going to type in this power of 132. Okay, so that's not a match, right? So, oh darn, back to the drawing board. I'm going to go ahead and try out choice B here. Change that to a 144, and hey, look at that. This is the same value. So answer is B. Okay, so you can use it here. You can technically use it here, not really here. Word problem, I'm going to say no to this one. Yeah, that's a nah from me here. Also, I don't really want to read this morning. So you can go ahead and do absolute values too, by the way. So you can either find it in the function tab. It's probably somewhere down here. It's in number theory now. It's not in number theory. So one of these, oh, here it is. Yeah, so if you use their like onboard keyboard here, you can find it. It's right here. Can you type in abs? I wonder if that works. Does that work? Yeah, it does. Abs works, but and then also I don't know if you have access to a keyboard. I think you will. You just use that shift and it's a button above the enter. Okay, anyway, 4x minus 4. So yeah, it's just going to give you an absolute value function. But when is this equal to? So if this is equal to 112, what is the positive value? What is the positive value of x minus 1? It's kind of a goofy problem. What do they want here? So this is the positive value here, which is what, 29? Yeah. And then you're just doing 29 minus 1 to get 28. Goofy. So don't do 29 here, even though the answer is, yeah, so that's what it's trying to say. So x is equal to, in this problem, this is x is equal to 29, and then also, negative 27. So I don't need to know how to solve an absolute value, right? I can just use Desmos. So I'm taking my positive solution of 29. 29 minus 1 is 28. Yeah, so geometry, not going to use it here. I have not touched a pencil. I have no pencil within my proximity. Yet I'm crushing this test. I don't know about crushing. Let's just assume I'm getting everything else wrong, right? I do think we're probably going to get like at least the average score by not doing any pencil on paper math. Okay, so I just went ahead and typed this in. What is the diameter? Okay, so I can just count. So I go from here to here, hopefully. And even if you can't do this, right? So it's like, shoot, distance between -1 and 7. I don't know what that is. Okay. Oops. Desmos can do it for you. So the choice is, answer choice is B here for 23. All right, so it's a circle. You're always going to get a circle. Okay, so you got some equations here. Exponential functions. So the value of f of 1 is k, where k is a constant. Which of the following is the equivalent? Which of the following is following equivalent forms of the function f shows the value of k as the coefficient or the base. As the coefficient or the base. Okay, is this just a goofy problem in its wording and it's trying to get us to type in these equations? Okay, I think I understand what it's saying. So type in these equations and which of these is the value of the coefficient in front. It's kind of weird. Like which of these f of 1 values is the coefficient in front. I'm going to just look at choice like B, for example. It just looks like the easiest to type in. I'm going to do f of x is equal to 80 times 1.6 to the power of x. You can do to the power of by doing shift 6. Or you can do this button right here. Anyway, so f of 1 here is 128. So this coefficient does not match this 128. I think that's what it's asking us to do. Yeah, I'm pretty confident that is what it's asking us to do. Oops. If you want to stay up in the exponent, so like right now I'm trying to type out C, you can use parentheses to stay up there. Yeah, what a weird problem. Okay, so I'm going to read it again. For the exponential function f, the value of f of 1 is k. K is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient? So this is the coefficient. It's a number in front of the expression. And if you find f of 1 here is 128. And this number in front of the expression is 128. So it's your choice C. Sometimes with these SAT problems, you got to read them a few times because you're like, what are you trying to say, man? Okay, 25 can, I have to read. Ugh. Okay, so model estimates that at the end of each year from 200. So the problem, yeah, this is just like a setup kind of situation. The number of squirrels in a population was 150% more than the number of squirrels at the end. You can use Desmos for this one. Sort of, yeah. So the model estimates that at the end of 2016, there were 180 squirrels in the population. Can I just sit here and just see when that's true? Ain't no chance. So models the squirrel population from 2015 to 2020. So shouldn't I just have 1 comma 180 within my equation? Ain't no way that's what they want. Ain't no way that's what they want. Actually, so if I'm looking for 1 comma, I have two choices. I can either look for it on the graph, find the 1 comma, but that's just going to take so much time. It's like, ugh, do I really want to sit here and find 1? Actually, yeah, look at that. 1 comma 108. So that's not 1 comma 180. So it's not going to be choice A here. What you could do instead is you can just type this as f of x. Just find f of 1. So that's not a match. Let's try the second choice. Hey, look at that. 180. So, okay, so there was a little bit of reading interpretation here. I know that the graph starts, like your T0 is to 2015. So your T1 is 2016, right? So 1 year difference. And then it gives you the population of the squirrels. So at year 1 on the graph, because it starts at 2015, 180 is your output. And you can find it up here too visually if you prefer. You can also do it this way. You can just say y is equal to 180. That's your squirrel population, your output. You can look for that point of intersection that way. A few ways. So yeah, Desmos can do it. Man, I just had to read there. You're welcome. I actually do like reading. Just not SAT word problems, All right, 5x. So this one looks like you can solve. Man, how much of this test? It's like half the test, right? We're solving half the test using Desmos. Crazy. By is equal to 1. Okay, so what is it? See, I didn't even read the problem here. In the given pair of equations, A and B are constants. The graph of this pair of equations is a pair of perpendicular lines. So you do need to know perpendicular. So yeah. Perpendicular slopes are opposite reciprocals of one another. Did I just find it already? That looks pretty 90 degree looking to me. perpendicular slopes are opposite reciprocals of one another. So you actually can sit here and solve for y for each of these, and then find your opposite reciprocal ends, your slopes of your lines. I wonder if that would be helpful here. Which of the following pairs of equations also represents a pair of perpendicular lines? Yeah, I think that's maybe the best approach for this one, to solve for y. So this one has some light solving piece to it. I'll still try to solve it without having to touch a pencil. That's a fun little challenge here. So what I did was I played around with these values here. And what's kind of interesting about this is that, okay, so like I created another, I don't know if that doesn't quite look 90 degrees. I would have to sit and solve for y on these. So I'm going to do some light solving. Hopefully you don't mind. And here I'll use Desmos to verify that my solving is correct. Just solve for y here. So move that 5x over and then divide by 7. So y is equal to negative 5 over 7x, and then plus 1 over 7. You can see these are a match because they overlap one another. So I keep turning this on and off, and they're the same line. So I can say, get out of here. I don't need you anymore. And I can solve for y here as well. So I'm going to move that ax over. So this is going to be like what? Negative ax. Here, I'll go ahead and create a new equation for this one. So it's the red line I want to try to replicate here. So negative ax, and then this is going to be over b, right? So divided by b. And then that'd be 1 divided by b, so 1 over b. Oop. Okay, there you go. Took me a sec, but hey, he got it done. Okay, so I want these to be opposite reciprocals of one another. So I know that the opposite reciprocal of negative 5/7 is 7 over 5. So switch that. I can actually bring this to negative 7 because negative negative makes a positive. And then I just make this a 5, and hey, look at that. These are opposite reciprocals. So I don't know. Would I say this is like a Desmos space problem? A bit of a stretch. But yeah, these are perpendicular to one another. So now I would just play around with, trying to create. So you have like your A and B values. Okay, we just found them. A is equal to, say, negative 7, and B is equal to 5. So we can sit here and we can just graph all the solutions now. Is this the best way of solving this problem? No, but Desmos can still handle it for us. I would probably just, at this point, plug in my A and B values and then solve for y and just look for those opposite reciprocal slopes. But anyway, I'm just I'm going ahead and graphing to see, like, I'm looking at choice A right now. So you would probably lose time on this problem by doing Desmos. And I'm going to turn these off for the time being. Like, these are definitely not perpendicular to one another. I'm going to try out choice B. Nice thing is I don't have to do too much retyping. All I have to do is change this to a plus, and those appear to be perpendicular, right? So choice B. I would probably just do this one by hand, but Desmos can do it. All right, the grand finale. Usually these quadratics suck, so let's see how this one goes. In the given equation, c is a constant. The equation has no real solutions. If c is greater than n, what is the least possible value for n? Wait, this is not bad. So I'm going to just type it on in. Plus c is equal to 0. C is constant. The equation has no real solutions. Can I create a slider for c? Oh, I'm going to set it equal to y and then just look at the y-intercept, right? Whoa, there's that quadratic. All right, so I'm going to scoot this up, and it's like, oh no. I always have 2 solutions. Shoot, Desmos can't do it. JK, I can actually click how far my slider goes out. So I'm just going to go from like negative 100 to 100, which is a little silly, but oh, actually it still doesn't handle it. Dang, I'm going to go from negative 1,000 to 1,000. Whoa, okay. So there's like some magical moment. It's, I don't know, between 280 here and 310. So I'm going to go ahead and change that. 280 and 310. Aha, it's right here at 289. I found you. Yeah, because so the moment that you make this C value larger than 289, there's no solution. So answer is 289. Desmos can do it. That's it. So I don't know, in the second half, because why not just count at this point? But it couldn't do it here. Could do it for the 3. So that's 1. That's 2, 3, 4, 5, 6, 7, 8. I don't think we used it here. 9, kind of 10. That's a bit of a stretch. 11, 12, 13, 14, 15, 16, 17. What? even can, you know, just take a few of those silly ones out. Like still half this test. Yeah. So Desmos, little busted. A little busted for this test, but great tool. I suggest you use it. I'm going to continue the math on. I hope you do the same. Good luck on your SAT.